Okay, so the question is about systems of equations and the matrix representation of that system of equations. And so we're given this shorthand right here of this augmented matrix. You've got this 2 by 2 matrix, 1, 3, 0, 2, augmented by this 2 by 1 matrix, 10 and 8. And this is supposed to represent a system of equations. Well, how does that work? Like I said, this augmented matrix is a shorthand. If you look at this first part, this 2 by 2 matrix we're going to call A. This 1 by 2 matrix, 10 and 8, we're going to call a vector B. And what the equations are the matrix A times some vector V is going to equal this other vector B. So in this case, like I said, A is equal to 1, 3, 0, 2. The vector B is equal to 10 and 8. And vector V is a vector of our unknown variables. So in this case, we can say vector V, and because they're variables, we can call them anything. Vector V is going to be equal to, we could call it X and Y, let's just say. So if we expand out the shorthand notation here into something a little more meaningful, we're going to say that these equations can be represented as 1, 3, 0, 2 times X and Y is going to equal 10 and 8. And so all you have to do then is do some matrix multiplication on the left side here. And for the top row, we'll go 1 times X plus 3 times Y is equal to 10. And on the bottom, we're going to have 0 times X plus 2 times Y is equal to 8. Or this just reduces down to X plus 3Y is equal to 10. And 0x plus 2y is equal to 8. Now, because it's not specified here, like I said, this vector v of variables can be anything. We could have called it a and b, in which case this would have been a plus 3b is equal to 10 and 2b is equal to 8. Even if we'd switched the variables around, even if we'd said that v was actually equal to yx, if we'd reordered the variables, that'd be okay, so long as we were consistent, in which case you can show that the answer to this would be, or the system of equations then would become y plus 3x is equal to 10, and 0y plus 2x would be equal to 8. So you can see the relationship between these two sets of equations and how they rely on the ordering of the variables. Now, there's nothing in the problem that says that v had to be equal to xy. We could have made it yx, we could have made it ab, we could have made it pq, we could have done anything. So long as we're consistent, both of these answers would be correct.